Hello everybody, welcome back to Trinity Software. Let's see about one of the powerful features of object-oriented programming called inheritance in this video. And we are going to see how this inheritance is implemented in Python. So let's see the definition of inheritance. We have a parent class and child class. The process of inheriting the properties of the parent class into a child class is known as inheritance. You can relate this with a real world relationship. For example, a child inherits the traits of his or her parents. Similarly, in object-oriented programming with inheritance, we can reuse the attributes and methods of the parent class in the child class. So, the class that inherits the properties from another class is called the child class, also known as derived or subclass. And the class whose properties are inherited by the child class is called as the parent class or base class or superclass. Seeing the benefits of inheritance, the main use of inheritance is to optimize the work of programmers. So the first thing is code reusability. We need not write the same code again and again. We can just inherit the properties we need in a child class. And as I have mentioned already, it represents the real world relationship between the parent class and the child class. And it is transitive in nature. Here we have three classes. If class B inherits from class A and class C inherits from class B, then this class C would automatically inherit from class A. It means that C can access the attributes and methods of the class A, even though it is not directly inherited from class A. So this is called as transitive. Now let's see how this inheritance can be achieved in Python. I have already mentioned how to create a class and object in my previous video. I have given the link in the description. Now we are going to inherit this base class using this syntax: class, the derived class name, within parentheses the base class, and whatever you want to put inside the derived class is written here. Features of base class is accessible to the derived class, and we can also define some new feature in the derived class. So this is called as subclassing. Okay, let's take the same example which you have worked in the previous video, account class. So this is the thing which you have written already. Minor change I have made here is I have passed the amount as an argument here in the function. Now let me create a derived class from this account class, class savings account as the derived class. Savings account derived from account class. Right now I am not going to do anything with this class, I just have a pass statement. So when I create an object for the savings account class, I can access all the attributes and methods of the base class account. Creating an object savings account with an account number 100. We'll print and check s dot account number. We'll call s dot deposit. Since the amount is passed as an argument, I am giving the amount here directly, s dot withdraw and s dot check balance method. On executing this, I got the account number printed, deposited, you have deposited, withdrawn and the current balance. All the attributes and methods of the base class has been accessed by this savings account class. Now let's move on to the types of inheritance. There are 5 types of inheritance in Python: single, multiple, multi-level, hierarchical and hybrid inheritance. You will see each and every type with an example. Single inheritance is the derived class is inherited from only a single base class. So thus enabling code reusability, and you can always add new features to the derived class. Take an example for single inheritance. There is one parent class with a function, func1, and a print statement parent behavior, and class child is inherited from the parent. It has a different function func2 and it has a print statement child behavior. Now I have created an object for child class and I am accessing the function 1 of the parent class as well as the function 2 of the child class. Both parent behavior and child behavior, both functions are accessed and it is printed. Next type is multiple inheritance. One derived class is inherited from more than one base class. So in this case we have 2 parent classes and 1 child class. We will take an example for multiple inheritance. We have two parent classes, parent1 and parent2 with different functions, func1 and func2, and child class is inherited from both the parent classes. So the syntax for inheriting from more than one parent class is this one. You have to mention the first parent class, comma, and the second parent class. And then the child class can have its own functions. So now I have created an object for child class and I am accessing function1, function2 and function3. Functions of both parents as well as the function of the child class has been called. So we have got parent1 behavior, parent2 behavior and child behavior. And multi-level inheritance is that we are deriving a class from class A. This derived class becomes a base class for another derived class. B is derived from A and class C is derived from B. You can correlate this with parent, child and grandchild relationship. So class parent has its own behavior, parent behavior, then child behavior, and grandchild has its own grandchild behavior. So creating an object for grandchild, we can access all the three functions, function 1, function 2 and function 3. Parent behavior, child behavior and grandchild behavior. All these things are printed. And the next type is hierarchical inheritance. From a single base class, you can have as many number of derived classes. So here I have made just only 2 derived classes, but you can have 3 or 4 derived classes also from a single base class. We have a single base class, parent class. From that we have 2 child classes, child 1 and child 2. In this case, I have created 2 objects. Object 1 is the object of child 1 and object 2 is the object of child 2. Okay, with the object 1, we can access function 1 and function 2. Function 1 is the parent class and function 2 is defined in the class child 1. Similarly, you can access function 3 and function 1 from object OB2, but you cannot access this function from child 2 and you cannot access function 3 from child 1 because these are not inherited. You can call it as siblings. For object 1, parent behavior and child 1 behavior. Object 2, parent behavior and child 2 behavior. Whereas if you try to call this ob2.function 2, you will get an error in this case. Got an attribute error, child 2 object has no attribute, function 2. And the last type of inheritance is hybrid inheritance. It's a combination of all types of inheritance. Here in this case we have hierarchical inheritance and multiple inheritance. So here we have one parent class with a function 1 and 2 child classes, child 1 and child 2. Okay? And child 3 is inherited from child 1 and child 2. Each has its own function. Now we have created an object for child 3 and we are calling function 1, function 2, function 3 and function 4. It will print everything, parent, child 1, child 2 and child 3 behavior. And in Python we have 2 special functions to check the relationship between 2 classes as well as to check the relationship between an instance and a class. That is isInstance function and isSubclass function. So this isInstance takes 2 arguments, object and class. So this function checks if the object is an instance of the class. And isSubclass function also takes 2 arguments, both are class, and it checks if the first argument class is a subclass of the second argument class. So we can take the last example which you have worked on. We can check both the isInstance function as well as isSubclass function. So after checking this, it's going to return either true or false based on the condition given. So I'm just going to check isInstance of the object we have created for child 3. We are checking if it is an instance of the parent class. Yes, obviously it is an instance of the parent class. Let's try that. We have got true as the output. Now let's try with the subclass function. isSubclass. I just want to check if child 3 is a subclass of parent class. Yes, it will also return true. So we have got 2 true statements. isInstance also returns true. isSubclass also returns true. So in this example, child 2 is not a subclass of child 1. In that case, it will return false. Verify that child 2 is a subclass of child 1. So it returned false. Now we are going to perform inheritance to this class account. We have already started with creating a class called savings account. So savings account is inherited from the class account. It means that savings account can access all the methods as well as the attributes of its base class account. Apart from this, it can have its own new features added to it. New attribute called interest rate and a new method called calculate interest. These things are added to the savings account. Calculate interest method should calculate the result of multiplying this interest rate by the account balance and then pass that result to the object's deposit method. And so the class should inherit all these three methods, deposit, withdraw and check balance, without redefining them. So before implementing this savings account class, we just need to know certain concepts in inheritance, that is constructor overriding. In our example, savings account, we are going to write a constructor in the subclass to initialize the attribute interest rate. So what happens when we write a constructor in the subclass? The superclass constructor will not be available to the subclass. You are going to override the constructor of the superclass in the subclass. So when this overriding is done, when the programmer wants to modify the existing behavior of the constructor in the subclass, we go for constructor overriding. So in that case, subclass object cannot access the superclass constructor. But what if we need to call the superclass constructor? In our example, we need to access that other attributes of the account class. So here we need to access the account number and balance apart from the interest rate. So in that case, we go for a special function called as super function. This super function allows us to call a method from the superclass. That method can be init method or any other method. So it gives access to methods and properties of a parent class. There is another alternative for calling the parent class method, that is an explicit call to the parent class method, parent.init self. You can just call like this explicitly. So this super function is a replacement for that explicit call. We can call the construct of the superclass using this syntax super.init. We need not give self parameter. If init function has any other arguments, that also can be mentioned here. This also works for any other method, not only for constructor, for method also super function can be used. So this is the savings account class we have created already. Now let me start writing the init function. Init self. I am just going to use the same init parameters. Self and num are the parameters used in the class account, parent class. Let me have a print statement stating that this is savings account. So now I am introducing a new attribute called interest rate. Let me initialize it as 0.02. Apart from this, we also need to access the attributes of the class account, that is account number as well as the balance. So for that purpose, we are using this super function, super.init, and we are passing num. So we have done with the constructor part. Now we have to write the code for calculate interest. So we have this calculate interest method. It doesn't take any argument. It's going to multiply this interest rate with the balance. So I take a new variable interest equal to self dot interest rate multiplied by self dot balance. So once we have calculated the interest, we will just have a print statement stating interest rupees. I am just printing the interest here. So we are calculating the interest and that should be added along with the balance. So instead of performing that addition separately, I'll just call the deposit method. In this case, while calling the deposit method, we need not use super because here the subclass is not overriding that method. So in method calculate interest, we are able to call this deposit function by just using self.deposit of interest. Deposit function is accessible to this child class through inheritance itself. That's it. So we have already done this. We are just going to include calculate interest alone here after deposit method. So on running this, we get the account number is printed first, then deposited 5,000 and interest is calculated interest is 100. It is again deposited using the deposit method. So after withdrawing 2000, you have the current balance is 3100. Now let's inherit one more class from the class account, a new class called as checking account. Apart from the attributes account number, balance and the methods, it has a new attribute called fees. This fees will be subtracted from the account balance whenever a withdrawal is performed successfully. So for that purpose we are doing method overriding here. So already the base class contains a method called withdraw, so that is overridden here. Withdraw method is overridden here and it should invoke the base class withdraw method to update the account balance. So that's what we are going to do with class checking account. So here we are going to see the concept called method overriding. This is similar to constructor overriding. Instead of the constructor, we are overriding the method. So the functionality of the parent class method is changed by overriding the same method in the child class. When the method has the same name and same parameters as its parent class method, only then the method in the child class is set to override the method in the parent class. So in our example, we are creating the checking account. We are going to override this withdraw method. In the parent class, deposit and check balance, these two methods are inherited in the subclass checking account, whereas this withdraw method in the parent class is overridden and withdraw method in this checking account class is the overriding method. We are going to modify the withdraw method in the checking account. So we will define a derived class checking account derived from the base class account. So def and just copy this thing here. We have this checking account statement here. I'm just modifying the checking account and we have fees here. Instead of interest rate, we have something, this attribute called fees. I'll fix it as 10 rupees. Also calling this constructor of the account class super.init of num. That's it. Now we have to override the method withdraw self comma amount. Now we have to subtract the fees from the balance. So self dot balance minus equal to self dot fees. Just print the withdrawal fees. You can just have the withdrawal fees is printed here. Okay. Now we have to invoke this base class withdrawal method. So for that purpose I am using super function dot withdraw. The parameter is the amount. I'm just going to withdraw this amount by calling this function. Let me change this itself. Checking account. We have deposited. We don't have any method called calculate interest. We are depositing, withdrawing and check balance. So account number is printed, deposited 5000, and when you are trying to withdraw some amount, you have withdrawn rupees 2000 and withdraw fees is printed. So and the current balance is 2990. Since you have withdrawn, the withdrawn fees is reduced. So that's it. If you like this video, kindly share and subscribe. Also don't forget to press the bell icon to get the latest updates from Trinity Software.